All right, moving on to 5.2. I kind of mentioned this is a big day. But 5.2 is just more extensions on the unit circle. Okay, so you're going to learn about your reciprocal trig functions and other relationships between those values on the unit circle. So if you don't recall, we've already covered the sine, cosine, and tangent ratios. So you know that your sine on the unit circle, your sine of any angle is equal to the y-coordinate. Cosine of any angle is your x-coordinate, and the tangent is your y divided by your x. Okay, now cosecant, depending on your previous math class, your exposure to these will vary. That's how you read CSC is cosecant, is always the reciprocal of sine. Okay, so these reciprocal one another. So if you know the sine is y, you know the cosecant is 1 divided by y, reciprocals. Okay, on that same note, SEC, which is pronounced secant, is reciprocal with the cosine value. So if you know cosine is x, your secant is 1 divided by x. And as you can imagine, COT, which is cotangent, that's the only logical name here, is the reciprocal of the tangent. So if you know tangent is y over x, then you know cotangent is x over y. You need to know those, okay? So what will you use those for? Here's an example, okay, and I kind of answered the first question, but given the point -12/13 and 5/13 is the point on the unit circle. Okay, well, you would show that x squared plus y squared equals 1. Yes, it is. I'm going to skip that part because we just did that. I'm going to ask you to find all of the 6 trig functions: sine, cosine, tangent, cosecant, secant, cotangent. Okay, so knowing this coordinate, normally I would say a coordinate is x, y. You should get comfortable with, instead of x, y, cosine, sine. Cosine is your x coordinate, sine is your y coordinate. So I know that the sine is 5/13, like I've got a freebie, and the cosine is -12/13. Another freebie, right? Like I know my cosine and sine values for this particular angle. By the way, I don't know what the angle is. Okay, then if you know that sine and cosecant are reciprocals of one another, then I know cosecant is literally just the reciprocal of the sine. So 5/13 becomes 13/5. Secant is the reciprocal of cosine, so it becomes -13/12. Now, how might you deal with the tangent and the cotangent? Well, it doesn't really matter which one you pick first, but if I just focus on the tangent, I know that tangent is sine divided by cosine. So I'll just write that out. Okay, if you multiply by the reciprocal, the 13s will cancel out, and that's going to be -5/12. So that's your tangent value. And now that you know the tangent, the cotangent is just the reciprocal of that, so -12/5. Okay, so just a basic application to your reciprocal trig functions and unit circle, of course. All right, why don't you pause this one, give it a shot. So you were given the secant is equal to 3/2. Okay, so I can fill that one in. Secant is 3/2. And right away, if I know the secant, I know the cosine because they are reciprocals. Okay, so that's, again, kind of a nice freebie. The sine is less than 0. Okay, so I'm just going to say, in other words, the sine is going to be negative. So I know this is going to be negative, which means the cosecant is going to be negative. So you can make some decisions. If the secant and cosine are positive and the sine is negative, think about what quadrant you're in. If cosine is positive, sine is negative, I have to be in the 4th quadrant, right? Because that's where cosine is positive and sine is negative. So that being said, you could actually just take your skills back to geometry. You could go into the 4th quadrant, draw your, it's kind of a lousy right triangle there. And I know that now I know, I'll probably just focus on the cosine over here. Cosine is equal to 2/3. Well, from my origin, cosine is adjacent over hypotenuse. So I place my 2/3 appropriately. use the Pythagorean theorem to figure out what my missing side is. So that's going to be square root of 5 plus or minus, but because it's going down, it's a minus square root of 5. Okay, that's option 1, which I think some of you are going to prefer. Well, now I can use that triangle to find everything. So if I go back to my theta here at the origin, sine is opposite over hypotenuse. Opposite is negative square root of 5. Hypotenuse is 3. So negative square root of 5 over 3. I can just use this triangle for absolutely everything. Cosecant is the reciprocal of sine, so that's going to be negative 3 over the square root of 5. Then you have to rationalize that denominator. So multiply by root 5 over root 5. So that's negative 3 root 5 over 5. So a little bit of simplifying. Okay, go back to your triangle and find the tangent. Well, from theta, tangent is opposite over adjacent. So that's going to be negative square root of 5 opposite over adjacent, which is 2. Reciprocal that to get your cotangent. So negative 2 over root 5. And you gotta
Nathan Friesner, please call 58021.
Gotta rationalize that one as well to get your cotangent. Okay, option 2, which I'm not gonna full out do, but you can use the fact that your unit circle is x squared plus y squared equals 1. I'm gonna go back to originally all I knew was these two pieces. So if I know the cosine, I can find the sine. Because cosine is x, and I'll just show you briefly this one side. X squared plus y squared equals 1. I know my cosine is x, so that would be 2/3 squared. And then from there, you can figure out y. And y is sine. And once you know sine, you know cosecant. And if you know cosine and sine, you can use those ratios to find tangent. Okay, so we kind of did something like that in this previous example. So you have options, which honestly is what makes some of this hard. All right, gonna end with trig identities. You don't need to memorize all of these, so I'm gonna give you a second to look over these. I'm gonna briefly talk about them. Okay, I already talked about the reciprocal identities, but I was using x's and y's. So you know cosecant and sine are the reciprocals of one another. So I could write that as sine equals 1 over cosecant as well. Secant and cosine are reciprocals, cotangent and tangent are reciprocals. Okay, we already covered those. Tangent is the ratio of sine divided by cosine, which means cotangent is the opposite, right? Reciprocal, cosine over sine. Pythagorean identities is what I did not talk about, but I will remind you that we did talk about x squared plus y squared equals 1, and you know that x is cosine and y is sine. So that should be familiar. Okay, that's where, that's all it stems from. Now, if I come over here and divide everything by sine squared, because that's legal as long as I do everything by sine squared. Well, what is sine squared over sine squared? It's 1. What is cosine squared over sine squared? Cosine over sine is cotangent. If I square both of them, that's cotangent squared. And what is 1 over sine squared? Well, if 1 over sine is cosecant, 1 over sine squared is cosecant squared. And that's where that stems from. Same idea, and I won't go through that again, but if I divided everything by cosine squared instead, then I will get this middle one. Okay, so that's where the Pythagorean identities come from. But again, you don't need to memorize these, so just write them down, take a picture of this, whatever you want to do. Here's what you're going to use them for. Okay, so you're going to be asked to write tangent in terms of cosine, and cosine of t, and t, the angle, needs to be in quadrant 3. So remember how I said this means something, it's a big deal. Okay, so quadrant 3, obviously over here, where cosine is going to be negative, as will sine be. Okay, so just keep that in mind as we do our work. So tangent in terms of means your expression can only have cosines. In terms of something means just that. So tangent, maybe the obvious first step is to write that as sine of t over cosine of t, okay, from the tangent ratio. I want tangent to be in terms of cosine. Well, right now it's in terms of sine and cosine. So this is good, this sine, not good. Obviously it's not cosine. Okay, so now I need to go up to my tools above and find a trig sine that I could rewrite in terms of cosine. So if you look at all of these, the only ones that connect sine and cosine and nothing else is this Pythagorean identity. It has sine and cosine and 1. 1 is totally fine. Okay, like you can have numbers. I should probably clarify that. So, I'm just gonna erase these so it's not confusing. So if I sidebar sine squared plus cosine squared equals 1, if I solve that for sine, it will stick with t's. I'm gonna subtract over the cosine squared. And then to solve for sine, I would square root both sides, right? Okay, now here is the part where I would plus or minus. In fact, I will plus or minus, and then we'll stop and talk about which one I'm gonna use. So here is where the quadrant is important. It doesn't matter where the tangent is in quadrant 3. It doesn't matter where cosine is in tangent 3. It matters where sine is. Oops, I didn't want to square it here, sorry. It matters what the sign of sine is in quadrant 3, because that's what I just solved for when I plus or minused. Okay, so this right here is what I'm gonna base my decision on when I pick my plus or minus. So in quadrant 3, sine is negative, so I want the negative answer of my plus or minus. That is confusing for many, so take your time because there's so many trig functions here to base your plus or minus decision on, okay? But based on this, if my sine is this expression, now I can go back up and replace this sine with that expression. So instead of sine of t, I would have a negative square root of 1 minus cosine squared over cosine of t. This right here is tangent in terms of cosine. And that's about as bad as it's gonna get right now. Okay, one more on that just so that you can get another example. Okay, so write the first expression in terms of the second. So I'm gonna write the blue in terms of the red. So again, in terms of cosine. So if you think about secant is the reciprocal of cosine, so probably a good place to start is this is cosine squared. Okay, again, keeping in mind I'm trying to get everything in terms of cosines. So I'm halfway there. Now sine squared is not in terms of cosine, but this one's kind of nice. I can, again, use this Pythagorean identity to rewrite sine squared t, if I subtract over the cosine, rewrite sine in terms of cosine. So now, substitution, I have 1 over cosine squared times 1 minus cosine squared from my Pythagorean identity, and everything is in terms of cosines. And it doesn't matter if they're squared or not squared, the ones are fine. You really could leave it as is. If you want to distribute that through, you could also have 1 over cosine squared minus 1. Either of these are fine answers. So that is secant squared times sine squared in terms of cosine. Ooh. All right, last but not least, and this is the easiest part of the whole lesson, is you will need to know how to type in basic angles on your calculator. So I have the TI-84 screenshot here. This is the TI-89. You need to check your mode, and you always need to be checking your mode. If you evaluate an angle in degrees, you want to be in degrees. If you evaluate an angle in radians, you want to be in radians. So you go to your mode button. Okay, so you really want to take a second and find that. It's pretty obvious, one of your main keys. So when you go to mode, you'll see this picture. Okay, 84s, notice right here, you have the option between radian or degree. And 89s, I showed the drop down, it says angle, and you're gonna get this drop down, and you'll have radian or degree. Don't worry about gradient. Okay, so you have to be conscientious. So if you look at my example, I have cosecant of 37 right here. Is there a degree symbol? No. no degree symbol, this is in radians. Okay, cotangent of 1.7, no degree symbol, this is radians. If you don't see a literal degree symbol, then it's in radians. The other thing I just wanted to make sure you were careful of when you type this into your calculator, cosecant, you don't have a cosecant button, but you do have a sine button on your calculator. So cosecant is the reciprocal of sine. So you reciprocal your trig function, but not the angle. Don't do 1/37. You do 1 over sine of 37. And same with cotangent, it's the reciprocal of tangent. So you don't flip the angle, you just flip the trig function. Phew, okay. So we're done. Take a deep breath. I hope you are so excited about trigonometry because it is my absolute favorite. And that's what all of chapter 5, 6, and 7 is on. Have a wonderful day.